Hello. Now I would like to show you how an application framework is designed. I find this article very interesting. It's a JUnit Cook's tour, and basically relates why the design emerges from needs of different requirements and how can you basically how do you design these complex things, although JUnit is quite simple, but it contains complex concepts. Okay, it's a nice piece of work in the sense that with a very simple design provides complex functionality and so, well, what I'm gonna focus. So, this article presents this in an interesting way. So, it's related with the 3 version of JUnit. Of course, now you have more code generation involved in it. So, you have annotations with 4 and 5, but basically the main concepts are the same. Okay. And so the idea of the goal, so the idea basic is that you have your test cases. And this is a bit, in some sense, you may think that is a bit strange because actually we have this idea that each test case should be independent and should be a single entity, a single object. But actually what you implement, as you see, if the test case implements the test interface, then basically you write your test cases, okay, inside a single class. But let's see. So the first requirement you have basically is that each test case, by being implemented, by being scheduled to run in some point. So when you execute the test runner, you go to each one of them. You should look at the test case actually as an object. So, and to look as an object that you can basically exists and then you decide when to run. So the best way to look at it is as an implementation of the command pattern, and where the execute is actually the run. So when you want to execute your test case, what you need to do basically is to generate objects for each one of the tests and queue them so that the test runner can say execute, 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 execute. So the first thing basic is just say a test case is an object, and it is an implementation of the command pattern. Okay, so we will have an object instance for each execution of a test. Okay. But then you have another problem, is that when you run your test, actually you just need to define the setup, the test, and the teardown. And you want to preserve this order, so this sequence in the order. And this should be the same for all the tests. So what is the pattern that you're going to use? I think that is already in your mind, right? Is template method. So actually your run should have a setup, a teardown, a run test, a teardown. And now the developer or the tester that is running the test, the only things you need to implement is to extend each one of these methods, implement each one of these methods. And then the framework will enforce a consistent execution of each one of the parts. So it will say that setup executes first, run test second, and tear down. Okay, so that's what happens. So actually, this is not visible for you anymore. So what is used for you is the extensions. This is the template method, is hidden inside the framework, and you only need to run the implement extensions. So, and the next step is, well, you need to collect the results. But I don't want the developers to worry about it. We need that this is inside the framework. So what they're going to do, basically, they are going to, each object that extends this test result, they create a test result that actually contains the results. And what is going to happen is that this run, that look, is not visible anymore. This is the run that is executed inside the framework. What your code is going to be the extension of this part, right? So, but this run actually receives a test result object. And of course, when you start the test, basically, you just send to the result, hey, I'm starting this test. And inside, this method can collect the information about the test. So in this case, basically, what it's going to collect is one test. I'm going to run one test. So it's quite simple so far. But then, and that's what it is doing there, okay? But then you basically, and this is called collect pattern. But then this evolves and you want to collect all the results. You want to collect errors and another thing that you want to happen is that if the test fails, you don't want the testing to stop. You want to catch this failure or to catch this error, collect the information about this, and goes to the next test, execute the next command, right? So how to do it? Quite simple. The only thing you need to do is to extend your template method. And now you just put all the code that deals with it and you just ignore it because we're just programming, setup, test, you're done. So you have all these and just a moment. And here it is. So now your template method is a bit more complex. So what are you running actually is what is inside here. So this is a, oh, sorry, you are implementing this, that, and that. But this part basically is the template method. So it can be a quite complex template method. But you just, as a tester, you just need to implement these small parts. The framework will deal with the rest. Okay? And now it comes the most challenging part of this framework. And look, if I have one test for one object for each test, so each test is different, right? So we need to create one class for each test. Well, that would not, developers would not love to write. One test, define a new class. One test, a new class. Actually, I want to define a class with several tests inside. But now the problem is, how do I decide a test case is actually an instance of this class? But the question is, which method, which test I'm gonna execute when I create one instance of this class? So if I have one class with 10 tests inside, actually I need to create 10 instances, one for each test method that is inside. How can I know which test I'm actually running? Okay, so the idea is to apply this pattern called the pluggable selector and then have an adapter class. So what happens? So each test actually has a name, which is the name of the method. And each time you run, actually you create an instance with that name. And that name is used to select which test to run, which is the name of the test. That's why in this first version, in the third version, the tests should have a particular name that finish with the string test. That's why they are able to select it. Okay? So now you have, suppose, 10 objects of the same class, each one of the same test class, which one for each method. And each object, the difference between the different objects, the 10 objects, the only difference is that name there, which is the string. That is the name of the test. And now the question is, which test I'm going, how can I be sure that when I execute run, I'm executing the test that have this name? Well, in this case, it's a bit more complex, and now it's the variation if you use different technologies. In this case, that was with the inheritance, that actually the test case that class is inherits from another class, and not using we are not using the notations of for instance JUnit 4 or 5. What they basically do is they use reflection, and by using reflection is that you use the name. They use the name to dynamically get the method of the class and execute it. Okay, so that's a detail that may vary with the language. For instance, when you do the testing with Spock, this is much simpler. Okay. And the final thing about it is basically now you want to run one test or two tests or 10 tests. You don't care. You just want to run tests, and one time you just go there and says, I want to run this method in this class, this test method. In other case, you say, no, I want to run all the methods in the class. Or in the other case, I would say, I want to run all the methods that are all the classes in the package. And other says, that's just, I want to run everything. What does it look for you? Composite pattern. So, actually, this is one test case and this is a test suite. What is a test suite? Basically is a set of tests. So you can create a test suite that is all the tests that are inside the class, and then you execute each one of them using the composite pattern. So I hope you have enjoyed how the JUnit framework was built, but that's the power of architecture and the power of design, and the power of is that although this was for JUnit, it was designed in the late 90s. Okay, what happens probably early 90s or middle 90s. What happens is that this design is there, and probably with slightly differences, we'll find this design in any testing framework. Unit testing framework. Okay, so I hope that you have enjoyed. I did. Okay, bye.